going over homework questions. Number 1, good stuff that you missed, sorry. 1 plus 1/4 plus 1/9 plus 1/16. I forget a common denominator of 16. That goes into 54, right? 3 times? No, 4 times. 64. The common denominator is?
Yeah, the common is, sorry.
No judgment.
It's 205 over 144. No, wait, that's the third one. Okay. It's, no, that's right.
So 4 goes into 144. 36 times. So that'd be 36 plus 9 goes into 144 16 times. And 16 goes into 144 9 times. Yeah? So that'd be 40, 52, 61.
Oh, you're doing like one end. Yeah, okay, that could work.
It is expanding. It's expanding lower. I don't want you guys to ever look at partial sums and be like, I know what it's doing, because as we came up against yesterday, if the sum of 1 over n squared converges from 1 to infinity, but the sum of 1 over n diverges, our brains can't fully comprehend just by looking at a series and saying, oh, hey, I know what's going on. We're not going to be able to do that in 2 or 3 or 4 terms, usually. But what I do want you to see is the sum going to 0? No. No, 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 right? Not even close. The terms are, but the sum is not. So what's the difference between a series and a sequence? A sequence says, oh, look at just the terms. A series, no, 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 it's all B. So yeah, it was tricky directions, but I really wanted you guys to do that problem because a series will converge if its partial sums converge. A series will converge if its partial sums converge, not the sequence. Turn the divergence test. Not the sequence, but the partial sums. If the partial sums converge. Now you're like, okay, sweet. Let's just get a formula for the partial sums. It's hard enough to do that for an arithmetic and a geometric, let alone some random sequence. Series. They throw at you. We're not making formulas for S sub n's. For arithmetic and geometric, we could do it. We could find the S sub n and literally take the limit. But for the rest of these, no. So instead, we have our tests. Yes. Yes. And you'll see why. Maybe today in the P-series test. Maybe not. But it has to do with the Forever card and Endeavor card number 12 that Kathy brought up yesterday with the improper integrals when you have 1 over x to the p. Very similar to 1 over n to the p.
Would a series converge if the change in each term lessened each time?
Good idea though. Because besides me looking at improper integrals yesterday, and the integral of 1 over n is ln of n that goes to infinity versus the integral of 1 over n squared that is a negative 1 over n that goes to 0. Besides bringing up the improper integral, how they work differently. 1 over n's terms, a divergent series, decrease. 1/2, 1/3, 1/4. So how much it's expanding by will look like it's decreasing. And in some ways it is. But still the series diverges. Because of how slow ln goes to infinity. So ultimately, all of your questions kind of come back to ln going to infinity. It does? You're just like, yeah, it does. It does? Yeah, it does. It does. Like, where's ln? But does ln go to infinity? Yes, which is a crazy idea in and of itself, just you probably never thought to question it. Or I made it sound so simple that you just never did. All right, let's go. Integral test. Endeavor number 16? 15. Ah, thanks. I couldn't remember where we started yesterday. Endeavor number 15. Are you sure? 12 was a special converging? Okay. 13 was geometric, 14 was, okay, got it. Thanks to the divergence test. And number 15, the integral test. Hey, to do the integral test, guess what you have to solve? Integrals. So are all the tests brand new stuff? No, geoseries was pre-cal. Nth term divergence test is taking limits to infinity of sequences. Sometimes telling you something, sometimes telling you nothing. Integral test, we're going to be finding integrals, but we have to know how to take all the stuff that we've done and apply it to the convergence and divergence test too. So if a sub n is equal to f of x, what did they just do? They took the nth term formula and said, let's put an x instead of an n so he can be a function. They took the points, and let's just call him an f of x, let's make it continuous. Why? Because they want to put it in an integral, and we can't put a discrete function in an integral. They're points. That doesn't make sense. But if we rewrite it as a function, put it in an improper integral. Maybe that's why I'm tying improper integrals in. But this test only works when? Look at the if before we go on. If, when you take the nth term, make it into a function, if that function is continuous, what if the function is discontinuous? Integral test fails or cannot be applied. What if the function if we can change the bounds to separate the negative to one side and the positive to the other side, we can use the integral test. Like if it's negative for a little bit and positive for forever, sweet. We can move that little negative to a little bit off to the side and look at the positive to forever part and use the integral test. Sometimes that's a thing. Same thing with decreasing. If it increases a little bit and then decreases forever, what we care about is the forever. We have to deal with a little bit, but we can use, as long as it's continuous, positive, decreasing forever, that's good for integral test. Then we can compare the infinite series with the improper integral. And what comes next? A really glorious conclusion. Because the integral test says if you can apply and if you can integrate. If you can't integrate, it's not a good idea, right? Like you're going to have to figure out some things eventually, whether they're integrable or not, whether they're able to be integrated by hand or not. Because an improper integral you can't plug into your calculator. So this is only helpful if you can actually integrate the nth term, but written as a function. If you can integrate, if the integral converges, the series converges. And if the integral diverges, the series diverges. So you guys already wrote down, use this test when f of x is easy to integrate, aka when the nth term written as f of x is easy to integrate. And once again, this test only applies with positive terms. And I'm going to put, if you guys are okay with it, 2. I know it sounds, yeah, we can do this whole like formula and have it go to infinity, blah, blah, blah. What I care about, the to forever part of the series, is that going to be always positive. It might start negative. It might start increasing. But as long as it eventually goes always positive, eventually goes always decreasing, we'll be okay. So to check the first 3 conditions, here's the dealio. Didn't I tell you yesterday, or maybe the day before, that with convergence and divergence, it's almost always multiple choice? Okay. So if it's almost always multiple choice, will you necessarily, like the L'Hopital's thing, have to totally solve, prove, show every aspect of how it's continuous, how it's positive, how it's decreasing? No. So could I make this whole show it's continuous step really complicated? Yeah, I could go back to the definition of continuous and say 3 things have to be true. That's brutal. What are typical functions that we know are continuous? All polynomials, all trigonometric, all sines and cosines, I should say. All polynomial x squared in there, all e to the x's, right? All ln's in its domain. Continuous in its domain, not like where you have negative numbers, but in its domain. Oh, wait a minute, aren't any functions continuous anywhere in their domains? Okay. How about rational functions? What do I have to watch out for? Rational ratio, ratio fractions, functions and fractions, fractions and functions. Watch out for the denominator, right? Radical functions, watch out for under the root of even power. Okay, so we're just going to watch out. I'm not going to make this a big deal with continuous. Watch out, okay? So watch out, check domains. We're not going to make it a big deal showing it because I honestly haven't seen an FRQ force you to show continuity for the integral test. needs to be true, but I haven't seen them force you to show it all nice and long and drawn out and improving language. Positive, what are we going to do? Look at it. But am I looking at it? Aren't I trying to get you to at least write out the first few terms? And here's a struggle. Where I see, well, you know what? I'm just going to put a note at the end. We'll come back to it. There are trouble functions that I see showing up that will confuse you for whether or not the function is positive and decreasing. Specifically about that whole, it might be positive and decreasing to forever, but there might be some funky stuff at the very beginning. But I'll talk about the trouble functions in a second. Decreasing. Couldn't I make that super complicated? Decreasing test. Oh, stink. We have to find the derivative charts. We have to see if it's, I could. But if I'm having you write out the first few terms, what could you be thinking of? Are the numbers going down? Right? Like, I know it's annoying, but literally, you can be looking and saying, are they going down? Now, do you need to at least keep in the back of your mind, there are some trouble functions where it's like, I'm not quite sure. But in general, you can say, are the terms decreasing? Okay? Because I don't want to make this test super, super, super hard. It's really important that these three conditions are met, because if they're not met, forget the integral test, unless they're met to forever, and we can deal with the beginning. It's really important these three conditions have to be true. And the reason I'm saying that is because if you use the integral test on a series where one of these conditions fails to the forever, you could get the wrong conclusion. Okay? Trouble functions, here it is. Log y. Let's just do ln. Okay? What do we know about ln's graph? In its domain, sometimes positive, but what is it for a little interval? Negative. The struggle with ln is once he passes his x-intercept. Now, I could just do it with any log base b of x. Okay? Any log. What's the intercept of any logarithm? Basic graphs, it's important. Logs hit y equals 0 when? What makes a log equal 0? All you guys have to do is a little bit of math. Whenever x equals, what's anything to the 0 power? Any base to the 0 power. It will always hit at 1, which is why ln of 1 is 0. Log base 10 of 1 is 0. Log base 7 of 1 is 0. Any logarithm of 1 is 0, unless there's like a plus or a minus or a shift or whatever. The intercept will always be at 1. So what does that mean? If I am looking from a series to a function, a sub n equals f of x, could it be possible that some logarithmic values at the very beginning could be negative? Yeah. Yeah. And so we'd have to be careful and we have to watch out. Almost always, if I see a trouble function where it looks like, let's go integral test, but it didn't meet until this term, it didn't meet until the second term, third term, fourth term, but then it's good to infinity, and we have to deal with the first, second, third term separately than the to infinity part. It's almost always a logarithm. Okay? So what if they say something like, ooh, ln of 2. Oh, don't worry, it's positive. What number is it? You don't know. I don't know. It's something close to 1-ish, because 2.718 raised to what power is 2? A little bit less than 1. But you don't do mental math with logs. Neither do I. But we have to still be able to say it's positive or negative. Does that kind of make sense? Cool. Let's move on. Aryan.
Quick, in the further part, it says, like, integral from 1 to infinity. So do we even have to consider before 1?
There are some series that can be written starting at 0, in which case the integral would start at 0. Make sense? But the nice thing is technically the integral test can be adapted. You can go from k equals 2 and then 2 to infinity, 3 and 3 to infinity. And sometimes it's what we have to do. Okay. But Aryan did just bring up a good point. If we are going from 1 to infinity, would we have to worry about good old-fashioned ln? No. But ln shifted, maybe. If it was like ln of x minus 3, we might be in some trouble. Okay. Shoop, shoop. So guess what? Let's practice. Integral test. Or nth term test. Or geoseries test. Oh, we have all three now. You're just understanding why we're taking a halfway quiz. Because we're only going to have like 5 or 6-ish tests. Let's just practice with those before we learn the others. Okay. But that's also good in homework, isn't it? Because every time you get to a new section, shouldn't you technically be testing or checking to see if one of the other tests would have been better? Yeah. So for instance, what do you think I want you to do right away? Write out the first few terms. Why? What if it's geo? There's nothing to an nth power. It's not geo. I need a ratio to an nth power to be a geometric series. Just letting you see the series and think about it. What if it diverges? It's not going to as it goes to infinity. Pause. Necessarily diverge. Because the limit as n goes to infinity is 0. We know nothing. But it's good for us to think about the other two tests. When you guys plug in, what'd you get? 1/2 plus 2/5 plus 3/10 plus 4/17. Question, are they positive? Yep. Are they going to be as go to positive infinity? Yep. Are they decreasing? Really? Yeah. Because wouldn't that be 2.5 over 5 to be 1/2? Wouldn't that be 5 over 10 to be 1/2? I mean, that would be 4/10 to be 2/5. Anyway, good. Continuous. Wait a minute. Hold on. Let f of x equal. You guys know why I'm starting there, right? We take the nth term, we make it into a function. We take that function and we say, since f of x is by 3 conditions, continuous. Is it continuous? No!
Yes.
Yeah, because the zeros would be plus or minus I, imaginary numbers. Forget that. Okay, so it's continuous. Check. Is it positive? We already said that. Check. Is it decreasing? Check. Sweet. Do I want you to show any more work than that? No.
Wow.
Integral test applied. Now what are you allowed to do? The integral test. Sure. I err on the side of writing everything out because as you guys write it out and as you hear it and as you practice it, I don't want you to miss any pieces. Int, sure. Just be careful, it could be integer, but in the broad things. So now what do we do? Let's go. B goes to infinity. Why am I just going straight to B going to infinity? Because? Yeah, improper. Why am I going to go to U sub? Good. Because I can. Could it be nice to do some work off to the side and not write something wrong? So maybe instead of having to worry about a limit and bounds that are x's instead of bounds that are u's, we just kind of think about our indefinite integral off to the side and say, oh, hey, so then we would divide by 2, so we have a 1/2, and then we have our 1 over u du. Oh, sweet. What's 1 over u du going to go to? Yeah, so let's just do ln of, who's u? See what I did? I didn't mess up my notation. I didn't try to write a definite integral with u sub. Gracias. I did mess up just actually writing the right answer, but besides that, go team. That's fine. I mean, it wouldn't be, but on a multiple choice, it'd be fine, right? Because is the 1/2 really going to make a difference? I don't think so. And then as b goes to infinity of 1/2, we're just going to pull the 1/2 out. ln of b squared plus 1 minus ln of 2. I'm going to infinity. So if it's going to infinity and beyond, what can I say? Therefore, if the integral diverges, you wouldn't use a sigma, you would say the series if you ever needed to do this, but that's okay.
What's the little sign for therefore?
Oh, you want to do the little sign? Sure. 3 dots.
Oh, I was right. What? I did that.
Means therefore. This one is there exists. This one means for all. That section. This way. You guys can see that one. Like for MVT, there exists. They know it. They should if they don't. Their table leader does. Okay. Ready, set, go.
I have an actual question.
Oh, on the last exam?
No. You can, it can just be like,
Okay, go ahead while I'm working.
okay, so there's only one test that can, like, is there multiple tests that can work for one problem? Or is it like, no, you have to...
There's multiple tests. So ultimately, when all 10 tests, which are in 8 letters, but all 10 tests, I am going to basically, and we're going to practice before we get there, I'm going to say, I need to see you use all 10 tests. So there could be one that 3 different tests are possible, and you have to strategically figure out, okay, if I use geo on this one, then I'm going to have to use this one on that one. Oh, I could use geo on that one and use... Yeah. I have to see you can do it, but I can't tell you which test to use. That doesn't help you. Got poochy lip in the back. It'll be all right. It'll be all right. Never heard of the poochy lip disease? I listened to Patch the Pirate when I was a kid. You guys don't know who he is, probably. Good life lessons. It's kind of like chapel and the whole, like, life lessons actually used to be a part of entertainment once upon a time.
My other teacher used to listen to him.
I love Patch the Pirate. My elementary teachers would, like, put in cassette tapes, and, like, during lunch or during rainy days, we'd just listen, or, like, if we got done early. There were, like, songs. He literally had he lost an eye to cancer. So he was really a pirate, yeah. It was cool. He was, like, a music kids pastor who lost his eye, and then he was like, I can do something with this. It was cool. It's like little stories. We should listen. I'm sure she did. I'm sure she did.
Yeah. And then she played him. That was so iconic.
Oh, that's how
I was like,
There was a camp food song. Yeah, Cuckoo Woods.
she played just like the music, remember? And she was like, yeah, I like kids' music. Oh, like pop on them.
That's good. I'll have to think of a song and sing it for you sometime.
That's funny.
All right.
She was this kid.
My mom had records of Patch the Pirate, and that was fun. Because I went to school with him, I went to college with him. Ron Hamilton. Oh, sorry, Patch the Pirate. You didn't want to know name. Los Santo. All right. I think it's positive.
Yes.
I think it's decreasing.
Yes.
I think we can use the integral test,
Yes.
right?
This is sick. So you have to use
Arctan. Since it helps you memorize the test, like then you'll be ready for your forever quiz where you have to know all the test word for word for whatever blanks I leave. Yes. Yeah. Except you in homework, just in class. Continuous comes first. Doesn't matter the order, it's just for my head to remember it. The problem is, after Patch the Pirate came VeggieTales, then all the songs that are popping in my head are VeggieTales songs. No, it's okay to hate VeggieTales. I totally agree with that, but not agree with hating him, but I don't know. There's some songs it's like, God is bigger than the boogeyman. Like, there's good stuff to that one. You know what I mean? Like, there's good stuff to some of the lessons in VeggieTales. Some of it's just ridiculous.
Lessons that it's just like I've seen it so much as a kid. Like I got so stupid whenever people like teachers would play it. I'm like, oh, what is this?
See, you should have told them. Isn't there like a guy named Patch the Pirate? Now you know.
The best was that one episode of VeggieTales where Larry, the tomato guy, what is the tomato guy's name?
Bob.
Yeah, and he's the king, and he's like really mean.
Wasn't that the Shadrach, Meshach, and Abednego one? Was Larry the king of Nebuchadnezzar?
Yeah, and he like had his rubber.
I think
neck.
that's the bunny one too, right?
Yeah.
The bunny, I ate the bunny. Yeah, there's that one.
Let's watch VeggieTales after our exam.
Okay.
Wait, wasn't Where the Hair?
Wait, Patch the Pirate.
Oh my gosh, yeah.
I used to sing that a lot actually around that.
Right? No, like there are practical songs in VeggieTales. Oh, where is my hairbrush? Right? Where? Yeah, my sister and I would do it nonstop.
I think that was the point.
That was The ironic humor. There's so much like funny stuff when you watch VeggieTales as an adult. It's hilarious.
Balls. Binge watch VeggieTales? Who's down? Start now.
Hey, I think we could all use some more life lessons. What? Come on, tan inverse. There's a pi over 2 asymptote, right? Minus pi over 4. Long story short, you don't even have to necessarily go further. Just be like, oh, hey. Therefore, wait, it's not 0. That's the limit of the nth term. That just means we know nothing. If the improper integral converges to any value, what does the integral test say? Yeah, the series converges. Done. Oh, sorry. Oh, this is an easy one. Well, like the integrals could get harder, right? Like you could have integration by parts, or you could have like some sort of weird trig sub, not trig sub. I mean, you could, but you won't.
No, this test, Misty, I literally got stuck on integration by parts. I felt so dumb.
I know a few people did when I was grading it. Oh, your test is graded. I totally forgot about that. Do you guys want them?
Yes.
Okay, go get your correction papers. I finished it last night. You guys can work on corrections over the weekend. Oh, I'm sorry. I thought you wanted it. Do you not want it? I don't. They're not graded. Ready, set, go. For those of you not getting correction papers.
Yeah, I'm just gonna grab like 10.
Ooh. 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 He did? I think everyone missed at least a little something, something. But some of you guys, your bonuses got you a little back something, something. And some of you didn't get you back as many something, somethings as you wished. Every problem ended up being up 6 points. And I gave you 4 free points just because 6 points only adds up to 96, but that's okay. You're welcome. Could have missed everything and gotten a 4%. Yeah. Not too bad. You gave 40 extra points. What? Let's start it at 40. All right, in no particular order. I think it's like when you turned it in. Riley, Sally. Oh, sorry, Sally. You're in the back now. Maggie. Arian. James. Naomi. I tried to get as partial as I could. Carrie. Hannah. Daniel. Kathy. Issa's gone. Justin. Deba. And Eric's gone too, right? Okay. You guys will have time. You guys can do like group collaboration, et cetera, next week also to figure it out. We kind of ran the full gamut, A's through D's. So some of you guys like were popping off. Some of you guys got stuck or made little mistakes that added up. There were quite a few little mistakes that added up. So take some time. Take some time in your corrections. Whoa, come back. I still have 3 minutes. Okay, when you plug in, there's an ln. 1 over 2 ln of 2 plus 1 over 3 ln of 3 plus 1 over 4 ln of 4. I don't know what ln is. Pause. Are they positive everywhere past 1? Yes. Pause. Is it decreasing? Well, what does ln do? Increase. And so the denominators are getting bigger. Not just the 2, 3, 4, but also the ln. So if the denominators get bigger, what happens to the number? Shrinks. So therefore, what can I say? Since f of x is equal to 1 over x ln of x and is continuous. Continuous? Yeah. My domain is everything greater than 0. I'm good 2 to infinity. Does that make sense? Continuous on the domain 2 to infinity. Positive and decreasing. Integral test, they're probably shorted by a comma somewhere, applies. So, let's go. Limit as b goes to infinity of 1 to b of 1 over x ln of x. Who's already thought of what to do? U sub. Good. Because can't I say u is equal to ln? Du is equal to 1 x. So couldn't I rewrite my integral to be, 1 over x dx could be du. I have 1 over u du.
So it's ln.
It's ln of,
ln x. Good morning.
well, technically, I guess,
I don't really know what that means.
ln of absolute value of ln of x, right?
Yeah.
But even though it's ln of ln of L, well, okay, technically. Wait. What should my bounds be? Why am I going to come back and say 2 to be? No, not they can't. They just went from 2 to infinity. Oh, okay, that's fine. Why?
It's 0 at 1.
I was actually thinking if you went from 1 in between 1 and 2, it might be possible that your function decreases. But from 2 on, you're okay. No, I think you'd be all right. 1, 2. No, I think you'd be all right. In other ones, you have to be careful, though. What do we have? ln of b. Oh, they're all positive anyway. Sorry, I was worrying about the absolute value, but it's not going to make a difference. ln of ln. Stop. Stop. Isn't this going to infinity?
Yes.
ln going to infinity is infinity, right?
Yeah.
So therefore, what are we going to say?
Therefore.
Pretend that was a sigma. Poor little guy. It's rough. Okay, you guys can work on corrections this weekend, but you'll have time next week to collaborate in groups on the stuff that you missed. Please start 9.3 OT. Sound good? The P-series test, super easy. If you want to look at it, it'll be in our notes. Some of you could bust out all of homework this weekend. Bye, guys. Whew, we made it. Bye, everybody who was gone.